Welcome everyone. In this video lecture, we will solve a problem which is basically from the MOSFET circuit at DC and from the book Microelectronics Circuits. So the question is calculate the value of drain to source resistance RDS obtained for a device having process transconductance parameter K and S 100 microampere per volt square aspect ratio W by L 10 when operated with a overdrive voltage of 0.5 volt. So basically we have to find the value of RDS. Okay. So this RDS we have to find when the device that is our this one is the characteristic curve for a NMOS having the drain current relationship ID and VDS curve. Okay, for a NMOS. Okay. So basically this drain to source resistance we have to calculate for a small VDS for a small VDS. Okay, and during that time, for example, during that time for a small VDS, this device, the NMOS, is in the linear region, linear region, or sometimes it is a the triode region. Okay, so in this case, the drain current equation in linear is generally written as K and S W by L in bracket VGS minus VT into VDS minus VDS square by 2. Okay. Now for generally for the calculation of RDS, this VDS will be very small. VDS will be really very small. Okay. So for a small VDS, the ID value is simply this K and S can be also written as mu n COX W by L. Okay. In bracket we can write VGS minus VT into VDS. Okay, and this value will be 0 for a small VDS. For a small VDS, this should be taken as VDS will be very small, so a square term will be nearly 0. Okay, so we have to neglect this one. We have to neglect this one, this term. Okay, for the a small value calculation. So now we have to find the RDS. Okay, so RDS is nothing but simply ID. Okay, means basically V equals to IR, simple formula. So we have to find the value of R. So R is V by I. So RDS can be written as VDS by ID. Okay, VDS by ID. So this can be written as 1 by mu n COX W by L into VGS minus VT. Okay, so this one is the general formula. We can say RDS equals to VDS by ID, the drain to source resistance. Okay, 1 by mu n CX W by L, and this VGS minus VT. Okay, I'm writing. One can also write the same equation as mu n COX is simply our K and S transconductance parameter, W by L, and this one is a VOV. VOV is our over drive voltage, that is our VGS minus VT, and this value is given 0.5 volt. It is given 0.5 volt. Okay, K and S, the process transconductance parameter, transconductance parameter is already given how much? 100 microampere per volt square. This is a very simple question, but we have to know some basic. This graph we have to know. Mainly the drain to source resistance we have to calculate, especially in the linear region when VDS will be small. Okay. Now another term W by L. W by L is also given, that is our aspect ratio. This aspect ratio is 10. So all data are given. Okay, this VOV is given 0.5 volt, K and S 100, and W by L 10. Okay, so everything we have to put in this expression. So RDS can be written as 1 by K and S. So K and S is 100 microampere. So 100 into 10 to the power minus 6 I am writing. Okay, ampere voltage I am not writing, into W by L 10 into, okay, VOV 0.5 volt, 0.5 volt. Okay, so now we have to calculate this one. So if we remove this decimal, this 10 will become up, this and this will be cancelled out. So this should be, if we solve, 10 to the power 4, okay, by 5. Okay, and we can write it 10 by 5 into, simple calculation is there, it should be 2. So 2 into 10 to the power 3, 2 into 10 to the power 3. So RDS will be 2 kilo ohm. So RDS, the value will be 2 kilo ohm. So this one is the final answer. The RDS value will be 2 kilo ohm. So we can easily find the RDS by using this formula. But from where the formula is coming, you have to go for this method, this approach. RDS PDS by ID corresponds RDS 1 by mu transmission parameter, aspect ratio, and overdrive voltage. So if you solve all these things, this formula will come, the same formula is similar to, okay, both are same. Now after putting every value, you can easily get the value of RDS. So this is all about this question. This one is also very important formula, drain current equation in the linear region. Okay, so this is all about all this simple problem, and it is from the microelectronics circuit book. Thank you.